Chapter 9, Stress Transformation. Let's review an interesting problem in stress transformation by application of Moore circle. So we want to calculate the principal stresses in this element. So if we want to translate this element in Moore circle, as you remember, every angles doubled in Moore circles. So 30 to 60 each. So we just, if we call this plane A and this one plane B, if you look at plane A shear of 150 megapascal and normal of 200 megapascal. The shear of 150 megapascal try to turns the element like a clockwise, so that point goes up by convention of circle. If there is a clockwise motion, turn the go at the about the x-axis. So that is point A. So the specification of point A is 200 normal and a positive 150 a negative. Likewise for the element B, if you look at the sample, so it just try to turn the sample counterclockwise. So just by the convention, it goes below the x-axis. So that's point B here, and B is again a 200 megapascal in normal, and this time a negative 150 of shear. So as soon as we have turned these two planes in two dots in Moore circle, and every angle goes double in. So this is 60 degrees, this is 60 degrees, and so if this is the 60 degrees, this is a 90, so this is small one by 30 degrees. So based off Moore circle, we can easily see this is sigma minimum, one of our principles, and the other one is sigma maximum, the second one. So from the figure, we can easily see this is our origin, this is our H, this is the center, minimum, maximum, and as soon as we get the sigma minimum, sigma maximum, we are done. We can record them like principles. So let's put it this way. So a cosine of 30 degrees, as you can see here, is like a AH over R, which we already know cosine of 30 is 1 over like sine of 60 square root of 3, half of square root of 3. So that's a cosine of 30, like a sine of 60 degrees, and that's based off our geometry, that's AH over R. So, and also we do note AH is our amount of shear, which is 150 on either side, either positive or negative. So this is now the only unknown here is R, and we can easily calculate R, and that gives us an R is equal to 300 over square root of 3, or 100 times square root of 3, and that's 173.20 megapascal in terms of the radius of our Moore circle. As soon as we have R, we can proceed the problem and calculate the rest of parameters. So if you look at the figure, you can easily see OC from O to C, which is the centroid, and that's our sigma average. That's OH plus HC. That's OH, O to C is OH, O2H plus HC. OH is already known to us, that's 200 megapascal from either side, and HC we already calculate this distance based on geometry. So, and also HC is R over 2. So that's a 200 plus we already calculated R was 100 radical and the square root of 3, and half of that is just 50 times the square root of 3, so that comes here. And OC, which is sigma average, is 286.60 megapascal. So we already calculated OC, which is sigma average. And if you look at to the nature of principal, sigma max is average plus R, and sigma mean is sigma average minus R. We already know sigma average is owed from the origin to the center of our circle is sigma average. Because that's simply sigma, yeah, and that's 286.60. And if you just add this number plus a radius, it just gives us sigma maximum. If you just subtract it from sigma radius, it just gives us sigma minimum. Then our sigma maximum is a 200 plus 50 square root of a 3 is a 86.6 plus 100 times square root of 3, and sigma mean is OC minus R and this numeric value. So sigma maximum in terms of numeric value is 459.80 megapascal. Sigma minimum is 113.397 megapascal. Thank you. We'll talk more about the circle and the relation of stress transformation in next videos. Thank you.